Alright, so let's have a look at an example where we get a non-right angle triangle. Alright, so what we have here is we have a description. Alright, and it's very important. We've no diagram here, so it's very important from the description we're able to, ultimately try and digest what they're saying and, develop a diagram that can sort of paint a picture for us, because ultimately if we have the diagram we can spot things a little bit more clearly, and allow us to do the question. So we have a vertical aerial AB that is 9.6 meters high, stands on a ground which is at an incline of 12 degrees to the horizontal. Okay, the stake connects the top of the aerial A to a point C on the ground 10 meters downhill from B, the foot of the aerial. Determine the two things, so length of the stay and the angle the stay makes with the ground. So let's try and see what is being said here. Alright, ultimately they're saying we have an inclined ground, okay, inclined to the horizontal. So what I'm going to do is I'm just going to set up a black line here that's going to state ultimately my horizontal. Okay, so bring that across. Now that is actually a terribly not straight line. Okay, again, this one's not much straighter either, but look, we get the idea, right? It's just not as bad as the first one. So there is our horizontal. Now what we're being told in this question is that we have ground that is inclining up from that, okay, say grass, a little bit of grass on the ground, inclining up there at 12 degrees. Okay, that's ultimately what we're saying. And that's going to, continue on. Then we're told we have a mast, okay, and we'll put our mast in purple. So an area, okay, it's vertical, so it's going straight up from this ground, and we know, so we variable AB, so we're told it's 9.6 meters high, and we're told ultimately at the top is A, top of the aerial A, and then the bottom point down here, that is going to be B. Now we're also told that there's a point C on the ground, so it's going to be on this green ground, that it's 10 meters. Okay, so we can say this is going to be 10, this distance here, B ultimately to C, and that there is a stay that connects A all the way down to C. Okay, and part A is to determine the length of that, so we'll call this X. Sorry, and we'll call this, that, never mind, call this X. Alright, so there's the scenario we've got, and hopefully we can see that in the purple we have a non-right angle triangle. Okay, so be careful, there's no right angle in here, okay, because although we've kind of straight vertical post here, it's then coming down at an angle, so we've no right angle there, so that's important. So we have a non-right angle triangle, so that's going to ultimately limit us to our sine and cosine rules to help us solve this problem. Okay, now what have we got? Well, we know two sides, and we don't know one of the sides, and we know no angles currently at this moment in time. Okay, so if we try to start off, say, with the sine rule, well, we could use this side, and we don't know this angle here. This side here, we don't know this angle in here, or this side, we don't know the angle down here. So we're kind of starting at a bit of a loss already. Can't use the cosine rule again because we don't know one of the angles, but let's see what can we find from the angle, because ultimately we're given this information down here, and we haven't really used it in the question yet, so that should be a bit of a hint that we should be able to use it somewhere. So what I'm going to do is, if I draw just from line B, if I draw a horizontal, okay, horizontal line straight across, and again hopefully it's straight, right? So we're saying this again is a horizontal. we're just bringing our horizontal up a certain distance. Alright, can't even spell. Horizontal. Okay, this is going to be parallel to this, to the horizontal. Well, then we know that the angle, the 12 degrees, will ultimately be replicated in here. We will have 12 degrees in there to do with our angles with parallel lines. And then also what we've got then produced in here is we now have a right angle, because that horizontal, once it's coming from that point, it's going to be at a right angle to the vertical post. So now ultimately we know that the angle B, okay, well actually really I should say the angle ABC is going to equal 90 plus 12, which would be 102 degrees. Okay, so now I have one of the angles, which is brilliant, because that will help me to start and solve, you know, what we're looking to get. So again, I can now go, right, can I use my sine rule? Well, again, you know, I don't really have, I need kind of another angle there, another side to use it, because again, this 9.6, I don't know that angle there. Okay, I could use those two to try and find x, but again, I don't know another angle to help us out, really. So what we're going to use is we're going to use the cosine rule, because remember, we can find the side from a cosine rule. So if we go ahead, we know when we manipulate the cosine rule, we can get a squared equals b squared plus c squared minus 2bc cosine of a. So if we replicate that to our example, we can ultimately say x squared equals 9.6 squared plus 10 squared, so they are the two sides that make up the angle, minus 2 times 9.6 times 10 by the cosine of 102. Okay, and then ultimately, when you type all this into a calculator, making sure your calculator is in degree mode, and then get the square root, you can find out that x will ultimately equal 15.23 meters. So we've done the first part. We've gone ahead and found the length of the stay. So now what we want to do is we want to find the angle the stay makes, okay, the stay makes with the ground. So that would be in here, this angle in there. I want to find that out. So what I'm going to do is, if we go on to a new slide here, I'm going to try and redraw out the triangle as we know it. Just the triangle. Okay, it looks something like that there. We know that was our point B, that was our point A, that was our point C. We found out in here that was 102. We know this was 9.6. And we are also told that this was 10. And we calculated using the cosine rule that this was 15.23. So that's the scenario we now have. And ultimately what we're trying to find, just put this in here, is the angle C. Okay, let's say that's opposite the side C. So what we could do is we can use now the sine rule, which would tell us, because we know this side, well, we're trying to find this angle and we know the side opposite it, so we can say 9.6 divided by the sine of C, and we know this angle and we know the side opposite, so we can put in 15.23 and divide that by the sine of 102 degrees. So we know a full pair, and we ultimately are missing one thing from another pair. So we can go ahead and manipulate that. That will give us 9.6 multiplied by the sine of 102 divided by 15.23 will equal the sine C. And then ultimately our angle C will equal the inverse sine of all that, 9.6 by the sine of 102 all divided by 15.23. And when we type that into a calculator, I'll go ahead and do, making sure our calculator is in degree mode. So we will get C equals 38.065 degrees, which will be checked back. 38.07 degrees. So that's a great example of a non-right angle triangle using the sine and cosine rules to solve it. So again, we start with a description. So we tried to digest the description, develop a diagram, very important part of it. Then we looked at what we had and what rules could we apply. Okay, we had to find out this angle by producing a new horizontal as well, just so we could incorporate this 12 into our diagram. Then we realized we could use the cosine rule to find one of the sides, because we knew the angle and the two sides that was producing that angle. Then when we did that, we updated our triangle to what we now know, and we could use ultimately the sine rule to find our this kind of angle that we're looking for. And then ultimately, even if you wanted to take that step further, now that we know the last two angles, or the two angles, we can find the last remaining angle, because all of them added up together should equal 180 degrees.